Hello everyone. I'd like to have a little summary and background information for all of you regarding nomenclature. So the discussion today will be the issue related to nomenclature. And in that, I want to talk about the nomenclature that is used for ionic compounds, and then we'll talk about nomenclature used for covalent compounds, and then we'll talk about nomenclature for acids. So in this discussion, we're going to focus on initially the ionic compounds. With respect to the ionic compounds, we have several issues that we need to address. And let's start with the concepts and the process. So first of all, an ionic compound is one in which there are ions, and the ions have a charge. Okay? And ionic compounds have a requirement that the charges must balance. So if we have a negative charge, so if we have two positive charges, for example, so if we have two positive charges, they have to balance with a requirement of two negative charges. And as you can see, this presents itself as a neutral compound. For example, if we had a calcium ion with a +2, we would need two negative charges. In this case, let's say that we used chloride. So chloride is a -1. We would need two chloride ions to balance it completely. So therefore, the structure in written form would be this Ca, which occurs once, and we'd need a subscript 2 for the formula CaCl2. And the way we would name this would be very straightforward. We would say the first part is named as the element, and in this case, when it's named as the element, this is simply calcium. And this would be named as the ion. So in this case, it would be chloride. So in this case, you can see that if we have a calcium ion, which you have to commit to memory that you understand it to have two positive charges, and the same thing is true for chlorine, chloride, you have to commit to memory that you know it is a single negative charge. So calcium chloride, by its very nature, is already configured as a structure for CaCl2. Let's do another one for ionic compounds so that you can see the process again. So let's say that we had a structure, for instance, like aluminum. Now aluminum, as you know, has to have an ion with a charge. In this case, it's a +3. So if we have aluminum with a +3 charge, we need to balance it precisely with exactly the same number of charges on both sides. However, suppose we had the polyatomic ion sulfate. The polyatomic ion sulfate, which is SO4 with a -2 charge, doesn't balance easily with respect to aluminum in the straightforward fashion. However, you can see that between the aluminum +3 and the sulfate -2, we'd have a common multiplier of 6. Another way to think about this would be if we have aluminum occurring twice, that's a +6, and then we put a parentheses sulfate, and that has to occur 3 times. You notice that you can think of this sometimes as a crossover, and now we have a structure for aluminum sulfate.